find the absolute maximum and minimum values of f of x equals 12 plus 4x minus x squared on the closed interval from 0 to 5. Now, we need to make sure first that this satisfies the requirements of the closed interval method, and sure enough it does. We have a function that's continuous, and we're looking on a closed interval, so we're good to go. To use the closed interval method, we're going to need to take the derivative of the function, we're going to need to find the critical numbers, and then we're going to need to evaluate the function at the critical numbers and at the endpoints. So we start with the derivative, f prime of x equals, well, the derivative of 12 is 0, the derivative of 4x is 4, and then minus the derivative of x squared is 2x. So we've got 4 minus 2x. Now this is never undefined, so the only critical numbers are going to come from when this is equal to 0. So we've got 4 minus 2x equals 0. If we add 2x to both sides, that gives us 4 equals 2x, and divide by 2, giving us x equals 2. And that is in the interval, so that is a critical number. And we also have the endpoints of 0 and 5. So what we need to do is evaluate the function at 0, at 2, and at 5. That is the endpoints and the critical number. And then whatever is the largest value is our global maximum. And whatever is the smallest value is our global minimum. So if we plug in 0, we can see that f of 0 is just 12. That's the constant term. If we plug in 2, that's going to give us 12 plus 4 times 2 is 8, minus 2 squared is 4. 12 plus 8 is 20. 20 minus 4 is 16. So that's bigger than 12. Then if we plug in 5, we've got 12 plus 4 times 5 is 20. And then minus 5 squared is 25. 12 plus 20 is 32. And 32 minus 25 is 7. So 7 is the smallest of these values. So 7 is our absolute minimum. So we have an absolute minimum of 7, and it occurs at x equals 5. And then the largest of those values is 16. So the absolute maximum, we've got the absolute maximum of 16, and that occurs at x equals 2. So those are our global extreme values.